All right, good morning, everybody. Let's do this. Lesson 5, solving exponential equations by changing the base or using logarithms. So before we actually go through the lesson, what I'd like you to do is have this quickly in your notes, and I'm just going to show you some nice, cool properties you could use to help you solve exponential equations. So here, let's look at this one. Notice that this says what? It says 3 to the x, right? 3 squared is equal to 3 to the x, right? So here, what does x have to equal? X just has to equal 2, right? Because if x is 2, then you have what? 3 squared equals 3 squared, so 9 equals 9. And, your life is very good. Let's look at the next one, though. Notice that because what this property is saying, it's saying that if you have some a to the x is equal to a to the y, notice when the bases are the same, the exponents have to be equal, right? So then what is this saying here? That x has to equal y. Here, the 2 has to equal x for both sides to match. Let's look at this one. Because the bases are the same, right? This is my a, and the a over here in this example is the 3. And here, this 2x has to equal 4. So x equals 2, right? And then why will this work? Because if x is 2, then what's 2x? 2 times 2 is 4, so 3 to the 4 is equal to 3 to the 4. And what is 3 to the 4? It's 81, all right? Now let's look at this one over here. Here we want to solve for x, and notice that here the bases are not the same. You see, this is a 3 and this is an 81. But notice this little trick. Notice that 3 to the 4 is 81, because 3 times 3 times 3 times 3 is 81, right? So if I have 81, what I'm allowed to do with this 81 is I'm allowed to change this 81 to 3 to the 4, right? And then here, what I'm going to have is this x plus 4 is on the outside, and this is 3 to the 2x. And notice how we went from the bases not being the same, now the bases are the same. But this just becomes 3 to the 2x. This doesn't change. But then what do you have to do here? Don't you remember, like, if I have some x to the y to the m, for example, this is x to the ym. What are you supposed to do over here? You're supposed to multiply this 4 times x plus 4. So it's 3 to the 4x plus 16. And now that because the bases are the same, you see how we have the same base just like this, that means the exponents have to be equal to each other. So 2x is equal to 4x plus 16. And now I could solve for x. And let's see, what is x over here? This is minus 4x minus 4x. Negative 2x is equal to 16. And then x has to equal negative 8. Okay? Oh, whoops, let me change the angle a little bit, sorry. Yeah, so here, my bad. That, I'll just review it again, that here, the exponents have to be the same, and then I got x by itself, and x is negative 8. And why does negative 8 work when I plug this into the original? Well, let's just take a look at this for 1 second. This is a check. Check. Oh, that's not how you spell check. Check. Okay, so here, if I have 3 to the 2x is equal to 81 to the x plus 4, right? What do I want to do? I want to check to see if this negative 8 works when I plug it in. So here, let's see, 3 to the 2 times negative 8 is equal to 81 to the negative 8 plus 4. So this is 3 to the negative 16 is equal to 81 to the 4. Let's see, negative 8 plus 4. I'm sorry, that's a negative 4. Okay. Now, why does this work? What is 1 over 3 to the 16? That's probably going to be a really big number. And 1 over 81 to the 4. Let's just use a calculator real quick to check this. So here, you could grab a calculator. And what is 3 to the 16? Notice that 3 to the 16 is 4, so it's going to be 1 over 4304671. And let's see, what is 81 to the 4? 81 to the 4. Notice you get the same, oh, sorry. My camera angle is very off, my bad. Notice that you get the same two numbers over here. So they are equal to each other. It's 1 over 4304671. And check, it works out. Let's look at the next property. Here we have, let's take a look at this one. Okay. Let's look at this property about logarithms. So for this one here, what this is saying that if you have some log base a to the x, what will this equal? All right, let's find out. If I have, for example, let's look at, oh, I feel like the camera angle is really bad here. Okay, what about this? No, this, okay. Here, notice, let's do this one first. Here, log base 4 of 16, what is this saying? This is saying 4 to what power is 16? So here, x equals 2. But look what I could do here. How would I solve this one? Notice that 4 squared is 16. So this is saying 4 to what power is 4 squared? And what this is, x has to equal 2, right? What this log 4, this log base a to the x, what it does is it cancels out this a over here and you're just left with x, okay? Let's try and look at some problems within the worksheet to try and I'll show you exactly what I mean by these two little tricks we could use. So here, let's look at the first one. Number 1, we're going to solve this one in two different ways. So this one is by changing the base, and this one we'll have as using logarithms. So there are two ways to solve this problem. For this one, if we have 2 to the x is equal to 8, notice that 2 to the x equals 8. Notice that to solve for this, you know, the answer is x equals 3. It's very obvious because like 2 to what power is 8? It's 3. But look what you could do. You could say 2 to the x is equal to 8 is equal to 2 to the 3. And here we're using this property that because the bases are the same, x has to equal 3. Okay? How can we use logarithms to solve this problem? If I have 2 to the x equals 8, what you're allowed to do is, which seems very strange, you're allowed to do log base 2 on both sides. And what happens here when you log base 2 both sides, it's the same example here that if I have some a to the x here, what the log base a does, it cancels it out. So what happens here is this 2 cancels out and you're just left with what the exponent is over here, which is an x, and that's equal to, how do you translate this? This is 2 to what power is 8, right? And that has to be 3. So x is equal to 3, right? And that's how you use changing the base or logarithms to solve these two problems. Let's try and look at this one together. Here, what would be the first move? I would, here it says 3 times 2 to the x is equal to 48. So if I divide 3, we have 2 to the x is equal to 48. Now, how can I solve this? Oh, I'm sorry, not 48. What am I talking about? 16. Now, how can I use these two different properties? So let's write it again. On one side, we're going to change the base. And on the other side, we're going to use logarithms. So using logarithms. Okay. Here, if I have 2 to the x equals 16, notice that 16 is equal to 2 to the 4. So 2 to the x is equal to 2 to the 4. If the bases are the same, then the exponents are equal. So x equals 4. Right? What about this one? If I have 2 to the x is equal to 16, what can I do on both? How can I get rid of this 2 so I just have the x? What you do is you log base 2 on each side. And now I have x, you see this cancels. If the base of these two bases are the same, then they get canceled and you're just left with the x. So x is equal to 2 to what power is 16, right? How do you translate this? 2 to what power is 16? That's 4. So x is equal to 4, right? And here we're just using two different methods to solving these problems. And that's what I want you to do for the rest of these problems. Is I want you to get used to being able to change the base to solve these problems, or to use logarithms to solve both of these problems. And I want you to do both. It's very important to be able to understand how to do both techniques to solving these problems. Okie dokie. All right. Enjoy.